welcome back. Today I talk about the board computer projects. For new viewers, I will start with the history of the board computer project. After I walk through all the hardware that I have made, I look into the hardware to the PCBs and I will demo the project. I am Brendan Koster and this is Brendan in Tech. My project started around 2.5 years ago. For my boat, I wanted a system that gives me a message if there leaks some water in. Because that wish, a friend of mine said, why don't you use an Arduino or a Raspberry Pi? I talked a little with him and I was not very convinced. But looking hours and hours on YouTube videos and learning myself how everything works, I thought maybe order some breadboards and some other stuff and let's try it and learn it myself. That was the start of my journey. And today, 2.5 years later, I have a complete system to show you. Most important is the board computer module itself. A touchscreen from 2.8 inch on the front, on the side a SD card and a UTP cable to connect with other hardware. Because this is quite small, I also have managed to make a little bit bigger version of 4 inch. And later I discovered the cheap yellow display. I've found a way to use this as board computer. Also, if I can use this as board computer, I can use the bigger version of it, the 7 inch version. Also, I think that's awesome. To do this, I've made this module. On one side, a GST125 connector, that's the same as on the cheap yellow display, and on the other side, a UTP connector, that is the same as on my board computer external hardware. Pro is that you now can use easy to buy displays as board computer. Con is that you can't use LoRa or GPS on a cheap yellow display, and that is possible with my board computer. The first external module for the board computer is the switching module. To connect this to the board computer or a previous module, you can use the FTP port with the arrow inside. To connect a next module, you can use the FTP port with the arrow outside. Connecting to the power of the boat, you do with the plus and minus, and this also powers via the FTP cable the board computer itself. The 8 other ports are to use for devices as output or sensors like flotters as input. This is 12-volt only. The second external module that I've made is the sensor module. This also have an FTP port with an arrow inside to connect to the previous module or the board computer, and a FTP port with the arrow outside for connecting to the next module. I believe also plus and minus for connecting to the power of the boat. Inside this module it is possible to place a buck converter to use for the output voltage a different voltage than for the input voltage. Each channel have an input, this is for a sensor, and an output. With a jumper setting inside, you can choose for each channel if you want an output and if that output is generated if the input is low or that the input is high, so it's reversed or unreversed. This output will be generated without interaction with the board computer itself, so if the software fails, the on and off setting of a warning light or a pump will not be infected. Besides of the automatically output, this also gives back to the board computer itself if the sensor is active or passive. In further terms of failing from the board computer, that can become door software, but also door hardware like a broken UTP cable. I've made a third module. This module I connect on one side to all outputs and the power of the switching module, and on the other side to the devices and power of the board. On top there are switches. The switch can on 1 for be what a board computer says, on 0 for always off, or 2 for always on. So if something fails, I always able to switch contacts. This module can nicely placed over the board computer switching module, so it's easy to connect everything and it is nice and clean. For all my hardware I've designed and ordered PCBs. For the board computer itself it looks like this. On one side a touchscreen, on the other side a Raspberry Pi Pico microcontroller, a buck converter, a Smith trigger inverter, and some connections like Wi-Fi, LoRa, and of course the connection to connect it with the external hardware. On most places I've placed female headers so I can easily remove parts like the touchscreen if something breaks. Then I can easily replace it without desoldering because I do not like desoldering. For the external hardware I most times use two PCBs. The first PCB is the logic PCB. This receives a signal via the FTP ports. It goes through the 7 ICs and that's pushed it to the 30 pins connector for the second PCB and also receives signals from the second PCB via this connector and give it back. Also, it has a daisy chain function to put the signal through the second FTP port for the next module. If soldering in SMD is not your hobby, I've also designed a true hole version of this. This works exactly the same, and you see there is here a buck converter in it. This is also possible to put in the SMD version, and this is meant that not all power comes from the buck converter into the board computer itself, but you can generate low voltage on the way. The second PCB in the switching module is the switching PCB. Input via the 30 pins connector will be translated to 12 volt. This goes through two fuses to the output. Here you can connect devices. Also there is a feedback loop from the output via a voltage divider to the 30 pins connector, so the logic module knows which ports are active and not, so you can see if a fuse is broken. It is also possible to put a sensor in it like a flotter. Via the feedback loop, the board computer knows which flotters are active and passive. In the sensor module is a sensor PCB. This has a few channels and each channel has its own circuit. In this circuit, the signal will be translated to logic voltage to the 30 pins connector and also optional with the jumper setting connected back to the output inverse or uninversed. On this side you can put in a buck converter instead of this strange jumper to give another voltage than 12 volt to the devices that are connected to this module. The last and easiest PCB that I've made, maybe the most important, is this one. This is for the bypass of the switching module. All buttons are connected to the switching module, but also to the 12-volt rail and via a automatically fuse to the output and the devices. As demo, I built this setup, the board computer, the switching module, and the bypass module. The board computer is via FTP connected to the switching module. That one is by 4 ports connected to the bypass module, and this light is connected by port 2. If on the board computer I turn on the second button, you see the light go on. And I can also turn the light off by turning it off. If the board computer fails and I still want to turn on the lights, I can switch on the second button by port 2. Then he's always on. If in another case the board computer fails when the light is on, but it can also be another device than a light, then you can also turn the light off by setting the button on 0. The switching module is not only capable in turning devices on and off, but also in readout binary sensors. If I mimic that with a wire by connecting the 12-volt with one of the ports, you see the black ball turns white and is almost not to see on board computer display. The board computer with the switching module is not only capable in turning on and off devices, but also in reading out binary sensors like flotters. Let's mimic that with a wire. You see the corresponding black ball turns white, and that means the channel is activated. There is a little bit delay, but that is not a problem. That's a few seconds. Nicer for connecting sensors is the sensor module. The sensor module have 6 breaking out channels, and each channel have 4 ports. The first port is for power, the second is for reading out a binary sensor, the third is for giving back a signal to turn a warning light or a pump on, and the last one is for ground. If I feed 12 volt to one of the ports input, you see the black ball turns white after a few seconds. You also note that I have placed 2 lights. The first is connected to the first channel in inverting mode. So when I feed the first channel, you see the light goes white. Nee. The first one is connected to the first channel and in inverting mode. So when I feed 12 volts or a lower voltage to the input of the first channel, you note immediately the light goes off. Also, after that few seconds, the board computer have read out the sensor status and say, hey, he is on, so the black ball turns white. Let's see. And when I remove, the light goes immediately on and the white ball will turn black again after a few seconds. Let's see. The second light is connected to channel 6, the fifth of the line. If I feed power to the input, the light goes immediately on, and after a few seconds you also note that the light is turned on the board computer display. Let's see. it's the lowest. And if I let it go, it also turns off and the white ball turns black again. At the moment, I'm busy with making new software for my board computer project. This new software have to be able to not only run on the Raspberry Pi Pico, but also on the ESP32. And with the ESP32, the cheap yellow display and the bigger versions of it. Besides that, I think the new software have to be a little bit flashier, so pictures in the menus are now an option. So look to the difference. This is the old version of the software and this is the new version. And as I said, it also does its job on the cheap yellow display, only I'm figuring out at the moment how to work with the SD card because that crashed the system on the moment. On the bigger version, it is a little bit scaled, so it looks strange, but you are capable to do a game on it, tic-tac-toe as example, and I should say try to win from the computer because the computer will try never to lose. He don't think in front, so it is possible to win, but it's not too easy. Besides as doing his job on switching devices and reading out sensors, my board computer project is also very nice in learning programming for making small games, as example tic-tac-toe. If you want to get started with my board computer project, go to my GitHub via the link in the description of this video. There you find Gerber files for each PCB and also STL files for the casings I have made. For each PCB I will make a separate short video that I explain what this PCB does, how you can check if everything works correct, and if I find some mistakes, which extra connections you have to make or which connections you have to broke. So as example, the first PCB that I made for this project, of one of the first, is this one. On the back I have to make 3 extra connections and I have a short on the front and that I have to break to work everything perfectly. All PCBs that I let see you right now are downloadable as you see them. If there are components on, then I also provide a BOM file and a placement file that were made for GOC PCB. I don't know how it works if you order it differently. So at first, the main board of the board computer, the bigger version of the main board of the board computer, the serial module to connect a cheap yellow display to the other hardware, the logic module with components, the true whole version of the logic module without components, the switching PCB with the fuses, that is the expensive one, and I also have a version without the fuses. You cannot put here fuses on or leave the fuses out on the other one because here is a hard connection and if you put here fuses on, the fuses don't have any function. Nee, dat is ook the bypass module PCB, the sensor module PCB, and for people who want to start with one PCB for the switching module, I have also the old version. This is the version where I tested with soldering self SMD components. This is possible. And I have this version without, so you only have to solder through whole components. That were the PCBs that I've made for this project. As I said, you can download them via my GitHub, and I wish you a very nice board computer project, and maybe you do something completely different with it. These were the PCBs that you can download from my GitHub. If you want to make a own PCB for my board computer project to expand it, please feel free to contact me, and we can find a way that more people can work on it, because that should be nice if more people work on the same project. I hope I've covered everything from the board computer project in this complete recap. If not, ask me in the comments and I will react to that. For now, thanks for watching, and until next time, goodbye!